Hello everyone, good afternoon and welcome to our webinar today. I am delighted to have you all here with us. We have an exciting and insightful webinar here featuring one of our engineers, Niyaz, as the speaker. He has been involved with the managed Microsoft SQL Server project for a while. So before we begin, I just want to mention that your participation and engagement are very important to us. If you have any questions during the webinar, please feel free to ask them in the Zoom chat. We will address them during the QA part of the webinar. So without any further delay, let's dive into the program. Over to you, Niyaz. You can continue.
Okay. So hello everyone. Is everything okay?
Yes, you okay? Okay, you can continue.
Okay. So hello everyone. This is Niyaz Murshid from AppsCode. I am one of the developers of KubeDB. So our today's webinar is about monitoring KubeDB managed Microsoft SQL Server clusters using Prometheus and Grafana. Then we will see a live demo. Sorry. Okay, so hello. Maybe I was muted, so let's continue. We will see first what is Microsoft SQL Server and some of the key features of it, and we will see how to provision SQL Server clusters using KubeDB, and we will see how to configure KubeDB managed SQL Server to monitor it with Prometheus and Grafana. And finally, we will show a live demo on the whole thing on the monitoring setup. And then we'll have a question and answer session that let's continue. So the Microsoft SQL Server key features. So as we already know, Microsoft SQL Server is a powerful and widely used relational database management system developed by Microsoft. Initially released in 1989, it has evolved over the years to become one of the most popular database systems for businesses of all size. So SQL Server is known for its robust performance, security, and ease of use. It supports a wide variety of transaction processing, business intelligence, and data analytics applications in corporate IT environments. So the SQL Server provides a powerful and scalable RDMS platform for storing, querying, and managing relational data. It has a language called Transact SQL, which is an extension of SQL that adds procedural programming elements such as loops, conditional statements, error handling to standard SQL language to making it higher versatile for database deployments. And for the high availability and scalability, Always On is a suite of high availability and disaster recovery features in SQL Server, which offers various high availability features such as Always On availability groups to ensure data availability and minimize downtime. So SQL Server supports horizontal and vertical scalability supports to handle growing workloads and data volumes. It can scale from small single server deployments to large scale enterprise deployments. So SQL Server provides robust security features to protect data from unauthorized access and ensure compliance with regulatory requirements. So it has industry leading performance, and it has support like various SQL Server integrates with Microsoft's business intelligence stack, including tools like SQL Server analysis service, reporting service, integration service, uh, to build comprehensive BI solutions. It has supports for advanced analytics and machine learning through integration with R and Python, allowing users to build predictive models and perform data analysis directly within the database. It has support for in-memory optimization, uh, and it has also support for integration services, which enables data integration and ETL processes, extract, transform, and load processes, allowing users to extract data from various sources and transform it and load it into the database. So for the use case, SQL Server is ideal for mission critical workloads and data insights. So SQL Server is commonly used for large-scale business applications such as ERP systems, CRM, and financial management. Um, and it's suitable for building data warehouses and handling large volumes of historical data. It can be used for web applications and content management systems, e-commerce platforms. SQL Server supports like analytics, reporting, and data visualization for informed decision makings. So, okay. Now let's see what KubeDB offers for Microsoft SQL Server. Sorry. So KubeDB simplify provisioning SQL Server clusters on Kubernetes. Uh, it has support for automatic leader election and failover using Raft. Raft consensus algorithm, and KubeDB supports multiple mode like always on availability group cluster mode and standalone mode, and it has support for custom configuration, authentication, and customizable health checker where you can specify the interval between the health check iteration and the timeout for each health check iteration, and you can also enable or disable write check for the health checks, and you can also configure like multiple the number of consecutive failures to mark the database not ready. Yeah, so and KubeDB also supports instant and scheduled backup, continuous archiving using WAL-G. So it has support for PITR, the point in time recovery support. And KubeDB ensures TLS secured connectivity among replicas and external clients using TLS configuration. And for the day two operations, KubeDB also has support for version upgrade, automated version upgrade, horizontal and vertical scaling, volume expansion, and reconfiguration of TLS. You can perform these day two operations by applying a simple manifest, YAML manifest, or maybe some clicks from the UI. And KubeDB also supports auto scaling compute and storage resources. And obviously KubeDB has supports for monitoring different metrics for your SQL Server deployment with Prometheus and Grafana. And we have support for production ready versions like 2022, CU14, and we are also adding new versions support. Now, let's see how KubeDB provision Microsoft SQL Server. So when KubeDB has a custom resource, custom CRD, for SQL Server named MS SQL Server. And KubeDB, when a user create the custom resource, KubeDB operator watches for the custom resource and creates necessary uh, pet set, PPC, secret services, and app binding, etc. For your SQL Server cluster. And the pet set is also known as stateful set 2.0, is a unique feature for cloud cost optimization. And this pet set feature is perfectly suitable for running database bots on different types of node pools. You can think of it as a smart stateful set. So you can read documentation for details about it. Now, uh, so for deletion of SQL Server, you know we have different termination policy support for, like if you set the termination policy to do not terminate, then when you try to delete that SQL Server, the deletion operation will be rejected by the operator. And you can use alt, which will delete the pods per se, but will keep the PPC secrets and snapshots that you can use to recreate the SQL Server again. And you can also set the termination policy delete, which will delete the PPC, but will not delete the snapshot and secrets that you can use to initialize SQL Server cluster again using the snapshots and secrets. Okay, now let's see for monitoring how KubeDB actually performs the monitoring operations, how actually the monitoring configuration is set up here. So when we enable monitoring, in SQL Server deployment, then for each pod, along with the main container and a sidecar container, exporter container also runs, which is actually responsible for the metrics, collecting the metrics. So when you deploy a SQL Server cluster with like n number of pods, then each pod an exporter container will run as a sidecar with the main container, which is responsible for collecting your metrics. So KubeDB will create state service, and a service monitor with appropriate labels for your SQL Server deployment. The service monitor will discover the service, essential the state service, with matching labels. So so that it can collect, it can be used to collect your metrics. And the Prometheus operator matches the service monitor based on the service monitor labels, and then it scrapes the SQL Server metrics to perform. Then it scrapes the SQL Server metrics to the Prometheus. And Grafana can be used. Grafana can use Prometheus as a data source, and can be used for exporting and visualizing the Prometheus scraped metrics. So this is a brief overview of the monitoring setup. Now let's jump into the live demo. So you have to like for the demo part, we have created a cluster, Kubernetes cluster, and then in your cluster, you have to create a cluster first, and then in your cluster you have to install KubeDB. You can install it using the help commands shown here. The latest using the version in our latest KubeDB version. And if you are not using KubeDB right now, you can get a license for 30 days trial period. You can check out our website kubedb.com for more details. So now We have to install Cert Manager also, which is required for TLS configurations, and also you have to install CSI type as CSRs, which add CS certificates to the OSTAR's trusted certificate issuers, which will add your custom CS certificates to the OS trusted certificate issuers, so that it verifies the certificate. Now you have to install the Prometheus stack, keep Prometheus stack using the help commands shown here. And for the KubeDB specific metrics, KubeDB has a tool called Panopticon, which is also required for scraping and generating different metrics for KubeDB specific deployments. Like it is a generic tool for which can generate metrics for any Kubernetes resource, native or custom resource. So for KubeDB managed resources, we use it to scrape different KubeDB specific metrics. And you have to install KubeDB metrics chart also for which will install the metric configuration for your database. Now let's see the sample YAML of MS SQL Server. So we'll see this in a moment. Yeah. So let's see the sample YAML for creating SQL Server using KubeDB. So like any Kubernetes resource, it has API version and kind and metadata and spec section. So and in the spec section, you can specify the version that you want to run. This version specifies the 2022 CU14, Ubuntu 2022. And for replicas, if it's a standalone deployment, then you have to set it to 1. And storage type is durable, means that your data will be persisted and PVC will be created. And in the TLS section, you have to specify the issuer name and kind, like a cluster issuer or issuer, which will be used to generate certificates for setting TLS configurations. And in the client TLS, if you set it to true, then TLS will be enabled for external client connections. And in the pod template section, you have to pass two environment variable. One is accept EOLA, which is required to accept the end user license agreement of Microsoft, and MS SQL PID, which is with the value that the edition you want to run for SQL Server. So like we are using evaluation edition now. And for the demo, and in the resource section, you can specify the request and limits of your CPU and memory. And this is the main part for our webinar today. So in the monitoring section, you have to specify the monitoring agent, like we are using operator here, and the exporter port and service monitor labels that is required. The service monitor labels that will be used to create the service monitor and the intervals of your scraping. And for storage class, we are using Longhorn for this demo, and necessary storage request and the deletion policy we are using for wipeout for this demo. You can use do not terminate or halt. that we have discussed already. And for cluster, SQL Server cluster, you have to everything is same as a standalone mode, but you can uh, you can in the replica section you have to specify the desired number of replicas that you want in your availability group cluster, and the topology in the topology section you have to define the mode like availability group, and then in the availability group section you have to include the databases that you want in your availability group. So KubeDB will create these databases and will add these databases to the availability group cluster for you automatically, and that's it. Everything is same. Now let's continue uh, with the demo. Okay. Okay. So use this. Okay. Then in your cluster you have to install KubeDB, the cert manager, CSR driver, CSRs, and Prometheus Grafana stack. So let's see what I have installed. In my cluster, I have cert manager installed, and the CSI driver CSRs also installed, which is required to add your custom CS certificates to the OS trusted store of the pod. And I have KubeDB installed. So these are the KubeDB pods: KubeDB Ops Manager, Provisioner, and Autoscaler, and the Webhook server, and the pods for PetSet and SetKeep. And I'm using Longhorn as my source class. And for the monitoring section, I have installed the Panopticon and the monitoring Prometheus stack code. So let's continue with the demo. For installing KubeDB, yeah, so you have to set feature gets MS SQL Server true to ensure MS SQL Server CRD installation. To keep Prometheus resource isolated, I used a separate namespace called monitoring to deploy respective monitoring resources. So we are going to deploy our databases in demo namespace. Now, let's. So I have already applied the MS SQL Server YAMLs, the standalone and cluster. So for the issuer, you have to create an issuer first for deploying your MS SQL Server. For creating your custom issuer, you can generate your custom CS certificates using commands like this. And then you can create a secret to hold these certificates. So secret is already exist in my case, and then you can create issuer. Uh, So this is the Azure CR that we have created, and then for the standalone SQL Server, so I have applied this CML, which which has the monitoring section enabled, and here, the agent, for the monitoring agent, I have used Prometheus IO/operator indicates that we are going to monitor this server using Prometheus operator. You can also use built-in Prometheus. And for the service monitor, uh, service monitor labels specifies that KubeDB should create service monitor with these labels. And for the interval, uh, uh, it indicates that Prometheus server should scrape metrics from the database with 10 seconds interval. Okay, now let's watch the resource created. So we can see that our MS SQL Server cluster and standalone both are in ready state with version 2022 CU14. And it has KubeDB has created the necessary pet set, port, and service and secrets. And this is the issuer that we have created, and these are the persistent volumes that is required for persist the database the data. Now, uh, now let's see that we KubeDB should create the stat service required for monitoring. So we can see that for the cluster, let's see here. We can see that for the AG cluster, there is a stat service, and for standalone, there is another stat service which is created for monitoring purpose. Now, let's describe. Now let's describe this service. Yeah. So notice the labels and port fields. This is the labels of this service, and in the port section we have we can see that the matrix port has 9399 port. So service monitor will use this information to target its endpoint. So let's see KubeDB created the service monitor or not. You can see that two service monitor is created for this. One is for standalone and another one is for cluster. And so this service monitor is created in demo namespace that selects the endpoint of the stat service. Now let's verify that the service monitor has labels that we had specified in the spec.monitoring section of MS SQL Server CR. So let's get service monitor. We can see that service monitor uh, has labels. Release Prometheus that we had specified in the MS SQL Server CR. Also notice that service monitor has selector which matches the labels we have seen in the MS SQL stat services. it also target the metrics port that we have seen in the state service. Okay. Now, let's find out the respective Prometheus pod for Prometheus server. Prometheus server is let's get the pod. This is the pod. So let's see the YAML. So the Prometheus server is so the Prometheus server is listening on port 9090. So we are going to use port forwarding to access Prometheus dashboard. So let's port forward this. Forward this port to access the Prometheus dashboard. Now we can access the Prometheus dashboard. Okay. You can access the Prometheus dashboard in localhost 9090. Let's refresh. Yeah. So we can see that the target for our standalone. Okay, we have to write cluster. So let's refresh again. Yeah. So we can see that now we can access the dashboard at localhost 9090, and we can see the metrics endpoint of the stat services and panopticon. So as the targets, you can see that for the clusters, for the cluster, SQL Server cluster deployment, the stat service, we can see that 3 endpoints for each of the pod. And for standalone, there is 1 endpoint. Yeah, we can see that the pod name and the service name and the endpoints, which is metrics for each of the pods. And we can see the targets endpoints for the panopticon and the Prometheus. Okay. So it verifies that the target is our expected database. Now we can view the collected metrics and create a graph. If you want to see the metrics, let's see the metrics. You can see the KubeDB state metrics here. SQL Server info, SQL Server replicas, and for the MSSQL database related metrics, you can see the MSSQL batch requests, connections, rate logs, for host name, ISTL seconds, and all the matrices that is scraped from the course. Now, using these metrics, you can create a graph from the homepage of this Prometheus dashboard, and you can also use Prometheus server as a data source for Grafana and create beautiful dashboards with collected metrics. KubeDB has dashboards developed for you. There are 3 dashboards to monitor SQL Server database managed by KubeDB. So to access and use KubeDB developed dashboards, you can go to the public repo on github.com/opcenter/Grafana dashboards. And here you have dashboards for all the databases for SQL Server. We can go to the SQL Server folder, and here we can see that we have 3 dashboards for SQL Server database managed by KubeDB. One is summary, which shows the overall summary of SQL Server instance, and for pod, it shows individual pod level information. And for database, it shows the SQL Server internal metrics for the database cluster. And you will see the dependencies required for this monitoring and using these dashboards. You have to install the Prometheus stack, Panopticon, and you have to enable the monitoring. So for using dashboard, you have to install the KubeDB metrics also, which actually installs the metric configuration for the DB. And now we have the dashboards here. We have to import these dashboards in Grafana to see the metrics. So we have to put forward the Grafana pod or service to access the Grafana dashboard. Let's put forward the Grafana service. Okay. So now let's log into the Grafana dashboard. Yes. So we can see that I have imported the dashboards by clicking this sign and import. And here you have to copy the dashboards JSON file and paste like this and click import to actually import. Here it says that a dashboard with the same name exists. Let's overwrite and import again. Yeah, so this is the database dashboard of MS SQL Server. Let's first see the summary dashboard. Yeah, so this is the summary dashboard for our MS SQL Server cluster, and we can see that the database status is ready, and from the terminal we can also see that the databases are ready. So let's check the version that we are running, 2022 CU14, and we require the CPU transport. That means TLS is enabled for this SQL Server cluster, and deletion policy is set to wipe out. And there are 3 nodes in the cluster. CPU request is we have set the CPU request is like 500 M millicode for 0.5 for each, so total is 1.54. And for the memory request, we used 1.5 GB for each, so total is 4.5 GB. For limit, we use 2 GB, so total is 6 GB. And you can see the CPU uses graph, And you can see the ports, port-wise CPU usage and request, and the memory uses, and the memory quota, and disk uses. So we are using like 66 MB, and for the MSSQL AG cluster 0, and disk read-write info, and IOPS throughput, etc. And yes, we can see the lots of metrics, and there are lots of panels with different metrics information. So this is the persistent volume usage history. We can see the transmit bandwidth and receive bandwidth. Let's see other dashboards. If we see the summary dashboard for standalone, we will see that total nodes is 1, and CPU is 154, and memory is 1.5 GB that we have specified in the YAML, and limit is 2 GB, and same informations for all. So let's see the pod dashboard now. Let's see the data, pod dashboard now. For the pod dashboard, you can, in the same way, you can copy the JSON file and import in the Grafana. Let's select the namespace for which is demo for this, and for pod, let's see the first pod of the cluster. Yeah, so we can see that the pod name is MSSQL clusters 0, and pod is running, and role is primary. So if we use EG cluster 2, like so, its role is secondary, and it's running for 2.7 hours. And you can see the server resource overview, and like batch requests per second, deadlocks, RAM used, and page faults count, etc. Git connection errors, and you can see the current database connections for the different databases, and develop log growth since the last restart, and total wait time for IOSTL for each database for read and write. And you will see the database wise read and write IOSTL time in graph. So if we see the standalone port, then yeah, specify standalone here. Let's see, we are connected properly. Standalone server is running. Let's go to the dashboard again, and we have to select this job. Okay. Okay. Standalone. Okay, so you can see that pod name is MSSQL standalone 0, which is running, and role as this is not a cluster, so it doesn't have any role like primary or secondary. So role is empty, and uptime is 3.8 hour. And you can see the server resource overview and the others panels. So let's now see the remaining dashboard, which is the database dashboard. Let's select MSSQL standalone, sorry, the namespace, and first three for MSSQL standalone. Yeah, so you can see that one instance here, which is MSSQL standalone 0, which is up and running for 3.8 hours. And for ability group cluster active replica, as this is not joined in any cluster, so it's 0 and there is no cluster status. And you can see the various database metrics and their information in these panels, like SQL compilation per second, REST request per second, and log growth, server connections, and total wait time of IO store for each databases and for read and write. So now let's see for the cluster. For the cluster, we have three instances, MS SQL AG cluster 0, 1, and 2. Each of if each one is up and each one is running for 3.8 hours. And for the AG cluster active replica, we have 3 for the primary. This is the primary, so it will show 3. The total replicas, the 3 nodes are connected with the primary, and for the secondary database, it will show 1. So this is the cluster status, primary, secondary, and it is fetching the data from Prometheus. So there will be another secondary here, and the other information are similar, like standalone. So yeah, so this is it for monitoring our for monitoring SQL Server using KubeDB. So let's continue to the slide. Now let's talk about the upcoming features. So we will add arbiter support to SQL Server Ability Group Cluster mode, because if we want to run even number of nodes, like 2 nodes, then there will be another node for required for the leader election and failover decisions. So you can run a 2-node cluster or 4-node cluster with an arbitrary node, which will only perform the only participate in the leader election and failover decisions, but will not store any data. And we will add remote replica support for the cluster. If you want to keep one replica in another remote data center, so that replica will be asynchronously connected and sync the data, and which will eventually used for any disaster scenario. If your whole data center is down, then you can shift your applications connections to that remote replica, and yeah, so you can recover from that disaster using that. And we will add new versions in our upcoming releases. That's it. If you have any questions regarding the monitoring and the overall SQL Server deployment using KubeDB, you can ask now.
So
Okay.
yeah, thanks Niyaz for the fantastic explanation with hands-on demo. We have come to the end of today's webinar. If you have any queries, feel free to ask now in the Zoom chat.
So,
I guess there is no question at this point. So thank you all for your participation, and we look forward to your presence in our future sessions. Visit our website appsco.com/webinar to check the schedule and register for our upcoming events. Wishing you all a great day. Bye bye.